Okay. Oz, in the meantime, how are you doing today?
I'm doing well. How are you?
I'm, my regular line, another day in paradise. I can't complain. I'm very predictable, I've been told.
It's your
Uh,
catchphrase. You have to say that.
yeah, I change them every few years, but every few years it takes some time. It takes me a while to find one that I like.
This
Uh,
shows that I don't know you long enough then.
you know me for more than a couple of years, but believe it or
Waiting for
not,
that transition to the next catchphrase.
yeah.
What's beyond another day in paradise?
Yeah, we'll see. We need to think about maybe we'll do a survey at the end of this, uh, asking for everybody's opinion. Good, fantastic. So I think we have really critical mass here. So we have a bunch of people on LinkedIn and a bunch of people on Zoom as well. So thank you everybody for taking the time and meeting Oz and I to have a discussion about lakeFS 1.0. We're super excited to be here. Just a few house rules before we start. Housekeeping rules. Uh, uh, Everybody, I think at least in the Zoom, is anonymous. If you have a question, you are more than welcome to click on Q&A and ask that question. When you ask that question, you can either give your name and then everybody will see it, or not see it, or ask it anonymously, and we will answer all the questions either live or we will answer them by writing answers on the Zoom chat. We will also repeat the questions on LinkedIn. If anybody has a question in LinkedIn, feel free to write those directly on the chat, and our colleague will actually translate them here also, so we'll be able to answer those as well. So without further ado, hi, Oz.
Hi, Do. Exciting
Yeah,
times.
exciting times, very exciting times. lakeFS 1.0 is out really after, I think, thousands of installations in productions and like we've seen hundreds petabytes of lakes. We've seen billions of API calls. We've seen a lot of intense usage of lakeFS. So we thought it's about time. So to kind of release 1.0. Now, since there's a lot of people here on the line, I actually would like to start by asking quickly, so we'll know what to focus on. Like, who do we have on the line? So, like specifically, should we actually cover lakeFS here? Are you familiar with lakeFS in the past, or should we just talk about new things in 1.0 and what type of roles we have here listening to us today? So I published a quick question. You should all see it in front of you. And if you can take just a few seconds to answer. Are you familiar with lakeFS? Not familiar with lakeFS? Have you played with it before? Okay, it's okay. Okay, so this could not be more evenly split. Oh wow. So okay, we got a lot of answers. Thank you. So I literally have like a bell graph over here about how familiar people are with lakeFS. So we have a bunch of people that are not familiar at all. We have some people that are active users of lakeFS, and we have a lot of people that are familiar, somewhat familiar, and played with it in the past. And we also have on the line data engineers and data scientists and other data practitioners and data professionals and ML ops guys and software engineers and everything else. So thanks for sharing. And so we'll do our very best to talk about all these to try and address everybody's question. But again, if you have questions, please feel free to put them on the Q&A. But before I guess we even start, how did we get here, Oz? What kind of started this entire journey with lakeFS?
So, if I had longer hair, this could be a very good representation of me 4 years ago. It's not me, however, but the situation was kind of similar. So this is kind of a story that, at least for me, was kind of this is when I guess everything clicked for me about why do we need something like this in the world. And the story goes like this. So it was 5 years ago, I think, almost to the day. I was working for a company called SimilarWeb. It's an analytics company.
I've heard of
And we
it.
had a data lake on top of AWS using S3 as a storage, like everything really by the book, working with our solution engineers from AWS, like ensuring everything is cutting edge the way it should be. And we had that one job that everyone really hated to touch on top of our data lake. It was called retention, right? A very naive name. And everyone really hated it. What it does is essentially delete data, right? What could go wrong? So essentially, you had something that deletes data. So if you mess it up, recovering from that is very hard. And on the other hand, it has to delete data on top of an 8.5 petabyte data lake. So testing it is also very hard. And like I was tasked, my team was tasked with 2 improvements that we needed to make. One, this took a very long time to run. There were many like business rules of what could be deleted, and the data is all very much interconnected, and like you had to make sure nothing is referring to the data anymore, and only then delete it. And so we needed to improve the performance of it, and we also needed to solve for a few edge cases of data that was supposed to be deleted but wasn't. And the good news is that at least on half of that we got it right, so it ran very, very quickly after we made the modification. The bad news is that we ended up deleting about 1.5 petabytes of data that was not supposed to be deleted.
Gone.
Yeah, and like we had object level versioning on S3, and we had like all the best practices, but just finding out of the 1.5 million objects that we just deleted, which ones were actually supposed to be removed, which ones weren't, and then restoring them all one by one, like this felt like, I don't know, back in the happy 90s, like you would FTP to a server, to your production server, and like modify the code directly there. This felt kind of like doing that. And I was like, we can't be like doing this on an actual production system. This can't be the cost of mistake. And I think like that realization of like, how can we treat, as data practitioners, how can we treat the data the same way we treat code, was kind of the nominal question. This is what kind of led to the path that eventually resulted in lakeFS 1.0.
Yeah, amazing. And because we have a bunch of folks on the line that are not familiar with lakeFS, although I understand that most of the people here are somewhat familiar, I'll go quickly. lakeFS sits on top of an object store, and that can be S3, Azure Blob, Google Storage, or an on-prem object store like Minayo or DLCS or NetApp Storage Grid. It's really like any object store will do. And imagine that you can take a bucket or a collection of buckets and you can give them a Git interface. So you can take this bucket and you can branch it, right? And then you can make changes and you can commit those changes. And when you're happy, you can promote changes to data by merging those. So really treating data as code in 20 minutes that you bring something up and you start working with it. And then all the ecosystem that we have of different tools can access the data through the lakeFS API and get these versioning capabilities. The only difference from a refactoring perspective is if before we were accessing a collection and a bucket, now we can include a name of a branch or a commit identifier. A name of a branch would be prod, test, dev, right? So for example, if I want to run my ETL in isolation, I can branch, create a staging environment, run my ETL in isolation, so I don't run a mistake in the retention ETL as I do it. And only when I'm happy with the solution, merge the changes. Or a commit identifier can be production yesterday at 5 p.m. before an ETL ran. So if I didn't capture an error, like in the retention back, I could just roll back in milliseconds. And then the Git actions themselves, those branches, those commits, those rollbacks, we can run them from a web interface, from a command line interface, like the lakeFS command that we see here, and from a Python code directly within a notebook. We're not going to go into details about the actual usage and things like that on this call, but there are plenty of examples that we had before, and please feel free to reach out, ask questions, Google us. There is a lot of other examples at a very high level. For those of you who are less familiar of lakeFS, the way that it works is that the data stays in place in any lakeFS offering. The data stays in place within your managed bucket. So you have a bucket and you have some files there at any format, right? This can be Parquet files, it can be Iceberg tables, this can be videos, images, annotation files, right? All the data stays in place within your bucket. And basically every commit in lakeFS is a collection of pointers to objects that sit on top of your managed bucket. And because the object store is immutable, we do copy on write. So if someone, for example, creates a new file, the next commit will point to that additional file. But files that did not change, like these 3 files over here, you will have multiple commits pointing to the same physical objects. Why is this so powerful? Because As I mentioned before, we have thousands of users that we are aware of, right? And as an open source solution, some of them have hundreds of petabytes of lakes. Branching out will be a super performant operation that will take milliseconds because we're not actually copying data. For the same reason, it also saves a lot in storage. So the way that our users use us is that every data scientist can have a copy of images and videos and whatever he wants for his models that he's working on, or her models that she's working on, without actually copying anything. Every data engineer can work on any ETL and any issue in isolation with a complete copy of the environment without actually copying anything, right? So that's pretty awesome. Also, when we go back in time, we can do that without the need to take snapshots of the same files over and over again in a data lake that often has many files that are static and a subset of the files that are added and removed on a regular basis. So that's kind of how it works. Just very briefly, if anybody has questions, please feel free to ask them on the Q&A or ask them on LinkedIn. Happy to answer. And of course, we can share a little bit more details. But let's talk a little bit about 1.0 in a more higher level. So what kept us busy, Oz?
Oh, yeah. So it's been a wild ride, I think, those last 3 years. So kind of a few areas where I feel that like ever since the initial release versus what 1.0 brings to the table, it's almost a completely different thing by now. For us, like we waited to announce 1.0, not just to make it like a nice round number. We really wanted to make sure that we can stand behind those promises that we made, right? Of being able to treat data the way code is being treated. And so the first concern, and this is something that was like from the ground up, one of the key requirements for lakeFS is the scalability factor, right? So as Idom mentioned, right, being able to work on top of hundreds of petabytes of data lakes, billions of objects, right? For me, if I go back to that retention job that I discussed a minute ago, almost 1 billion objects on a data lake, how can I make sure that branching is performant, that it doesn't interfere with the performance of reading and writing data, right? So all of this had to be in place. So a lot of improvements over the last few years, and especially leading up to 1.0. The data model from day one to what it is now to represent those pointers is almost completely different. It works on all the existing object stores at pretty much any scale. Like we haven't yet hit the mark where we say that lakeFS would not support that size. We just haven't found that limit yet. Hoping not to find it actually, but it's kind of amazing to see that progression.
Oz, before you go and you speak about the next one, there is a somewhat related question about the Q&A, which we can help identify. Ken was asking, is the focus on multiple file versions or version of a single file? Which I think just kind of fits in the scalability and the use case of what we're trying to do here.
Yeah, that's a very good question, and something that does come up often. And I think like when people look at Git versus what lakeFS brings, this is kind of one of the key differences. And that just like Git, lakeFS is completely agnostic to what do you actually store on top of it. But unlike Git, we don't try to like merge changes within a single object. So everything happens at the object level. That's the smallest primitive that lakeFS manages is an object. Right? And this maps really well to the way object stores work, right? I can't go into S3 and just modify a single byte on an object. I can either rewrite a new object without modification or just add another file. And for lakeFS, it would show you that, right? When you do a diff in lakeFS, it would show you which objects were added, which objects were removed, and which objects were modified, right? So that's kind of your most atomic piece within lakeFS.
Right, which makes it actually very useful for a different question that was asked and Q&A, which is it a good tool for running analytics that calculate diffs in a time series? So lakeFS is super useful in taking 2 commits, right, time series across 2 time period and comparing them. And actually, when we're going to talk a little bit about some of the new features that we did over the last 3 years, actually being aware of the data itself, like for example, a specific support for open table formats is one of the things that we do as well. So very useful in comparing data across time series, by the way, in integration with orchestration tools as well. And we'll give a little bit more examples as we go.
Yeah, absolutely. And I think maybe a key aspect on that question is what happens when you don't have just one time series, right? What happens when you have multiple collections? And now you just want to understand, I ran my process yesterday. This was the state of things. What changed since across all my data? And lakeFS makes that very efficient, right? Just by introducing an efficient diff. So that's a pretty cool capability. But kind of back to like our journey over the last 3 years. So we talked about scalability. For us, that's kind of one of our core tenets of what lakeFS has to provide. I would say that maybe another one that's just as important, it's not definitely not less important, is security. Right. So lakeFS, for better or worse, it's a layer on top of probably your most precious asset, right? Your data in the organization. So being able to make sure that whatever version you're looking at, so you have proper access controls, you have the right features for auditing, for role-based access, making sure that like the user identity is always provided from the organizational like repository of that. So we added so much from like the initial release where you just have like a user and a password. You go in and by default you see everything. That was kind of the beta version. To now where you have single sign-on with like your LDAP or your SSO providers with SAML. You can manage your security access controls through role-based access control, just like IAM. A lot of features and a lot of focus around that area. And of course, auditing, which goes hand in hand with versioning. All right, so being able to see not just what the data looked like, but who accessed it and when and using which tools, right? Being able to provide all that provenance, we see it as kind of a core part of the platform.
Yeah, I think one of the major things that I see from so for those of you who don't know, I by the way run customer success. I didn't introduce myself in lakeFS, and Oz is the co-creator of the project. But speaking with customers, that one of the main feedback that I get all the time is around the pre-signed URLs, which basically really minimizes the access that lakeFS needs. And I think that was a game changer in the field for us.
Yeah, so it's actually pretty cool because lakeFS now, you can actually deploy lakeFS in a way that it's able to manage data that it itself cannot even read or write, right? Using those pre-signed URLs. And that's, I think, pretty incredible, right? Being able to do so. So when you request an object from lakeFS, instead of like lakeFS proxying the bytes back to you, it would hand over back to the client a pre-signed URL that the user would then fetch directly. So all the communication between the compute layer and the object store is direct. And that's very powerful and really reduces kind of the blast radius, let's say, for any type of security related thing.
Yeah, it's funny. I often need to explain that very like a lot of times when people see lakeFS for the first time, they say it's kind of hard to grasp. How can you actually manage my files and my commits without the permissions to write and read to them? So I think that was again a game changer in lakeFS.
Yeah. Yeah, so the next one, and this is, I think, maybe the most interesting one. So when we initially released lakeFS, our focus was solely on like data engineering, right? ETL jobs, working with tools like Spark and Hive. We saw like a lot of things around tabular data, specifically in structured data. But one of the things that happened during those 3 years is that we saw kind of the market pulling us in another direction. Which is machine learning. And especially now when you talk about generative AI and LLMs, we see a very strong need for versioning from an area of the stack that we were actually not expecting, right? And this comes from very real problems that users are facing around those platforms, especially the newer technologies. I'm building a machine learning model, or I'm fine-tuning an existing foundation model. I'm putting this in production in front of my users, but I have no way of reproducing anything if something goes wrong, right? I ran this training job yesterday. If I run the same thing again, same code, same tools, I might get different result because my input data changes all the time, right? I'm reading from some path on an object store. In the meantime, Ido was smart enough and nice enough to change the schema, add more data, remove some historical data. If I run my training job again, I'm going to get different result. How can I tune anything? How can I modify anything safely? How can I debug? So we see a lot of interest from that area, and we decided to really double down on that. And it really matches kind of the lakeFS philosophy of being agnostic to whatever it is you're managing. So we see users using unstructured data and structured data, and very different like tools and environments. And we really started to double down on that. So we vastly improved our support for Python and all the tooling around Python. And this is still something we're continuing to do. And we recently released, for me at least, a very exciting feature called lakeCTL Local, which essentially lets you map some path on lakeFS. So out of my main branch, give me that directory locally on my machine, right? I just want to mess around with the data. Maybe I want to train a small model locally before doing it with a distributed compute layer. And to tie it back again with my code, right? So if I make changes to the data, put the version of the code that I was using to connect the two, right? So being able to do all of that.
Yeah, I think I'll before we speak on integration, just because you brought it up, because I think those are they're in the world of machine learning, and 100% like this is the exciting thing about a startup, right? There were a few changes, including lakeCTL, that made a big difference. One is just a flexible. I'm getting that my internet. Everybody hears me okay?
Yeah, I think you got cut off for a few seconds.
Okay, great. Good now. One is a flexible import at scale. So this is the ability to go and, in a single command, just bring data from many repositories or individual files, because this is kind of the day in the life of a data scientist that we see a lot of times of like, I need to get data from many different use cases, many different, data sources, and then I need to version that as I go forward. So that's one. And the other one is exactly that ability to work locally. So not only do we have the commits that are pointing to the files, but I can locally for my computer just run a local clone, and that will copy the files. And even more importantly, if I go and I decide to make some changes, when I commit those, it will go back and sync with lakeFS. And if anybody wants additional data or information about these, then we have a webinar. This is actually some documentation about how to import and different ways to import here on the left, and on the right we have a webinar recording about machine learning reproducibility at scale that Amit and I did, I think, just a couple of weeks ago. So these are really good ways for people to get familiar with some of those new features, because again, we're not going into the details on these calls. So yeah, absolutely, the machine learning was very interesting for us as we went into it.
Yeah, and it continues to be. And actually something that was just recently introduced, and that was as recent as yesterday, is that LangChain, which anyone who's working with LLMs is probably familiar with, now officially supports lakeFS using the lakeFS document loader. It's now part of mainline LangChain. So that's really exciting. And if we speak on LangChain, so I think that's also a good segue to speak about like the ecosystem around lakeFS. And the big focus that we put over those years on integrations, right? So one of the core promises for lakeFS, especially when like we try to adopt kind of the Git model of doing things, is that it should be as seamless as it can be when you integrate it into your existing stack, right? You don't say, okay, I'm introducing Git, so I have to stop using Java or stop using NPM or stop using any of my existing tools and adopt something else, right? It just seamlessly kind of melds into the background and does versioning, does it well, and doesn't really interfere with anything else. That's kind of the lakeFS approach as well. And for data, this becomes something that's a bit more challenging, right? You're not going to clone 8.5 petabytes of data to your machine. You want to work on an object store. You want to work with systems that know how to communicate with the object store. And we want to make it as easy as possible. So this slide is actually pretty incredible to me. And like, if I would look at this 3 years ago, I would be amazed that we've done all of this. But we've collaborated with pretty much any of the like leading players in the data stack to make sure that lakeFS works seamlessly with all the tools that you see here. And actually, there are quite a few that I can think about that, like this slide is pretty new, but already outdated. This list keeps on growing. So for the most part, you introduce lakeFS, you set the right configuration, and you're good to go. Right? You use the same tools, you use the same paradigms, but now you get the ability to click a button and get a branch, being able to roll back. You get all the capabilities without sacrificing like the technologies that you get to use. So for me, that's very exciting.
Yeah, it's funny because like this, the storage, for example, here is basically, it's not what we support, because we support anything that has an S3 interface. This is all the things that people are saying, hey, do you support that? And we say, I think so. And then we find out that someone's running it in prod and at scale. Some of these are where the scale was actually, for some of these were actually incredible to find out. But yeah, it's a partial list and it keeps on growing. And if we zoom to some of them, just like from the field perspective, right? There's a few things here that got more attentions than other, right? I think the storage makes, like, it's obvious, right? Like, yeah, there's just the ability to support literally any object store out there. But one of the things that got a lot of attention is the open table formats, specifically Iceberg and Delta. Those are the two that we kept hearing about. We hear a little bit about Hoodie, we hear a little bit about some others, but these are the ones that were all over the place over the last, I'll say, 6 months to a year, more than anything. And we developed specific support for both of them. So today, for example, when you use Delta Lake tables, if you compare, regarding the question about the time series data before, if you compare two commits in lakeFS, you won't only see like, oh, these Parquet files were removed and these Parquet files were added, but you'll actually see through the Delta log change the actual changes that were made. And by the way, we're adding additional kind of support to Iceberg also going forward. So it's pretty incredible to be able to have a user that can, you know, look at the huge repository compared to whatever different time zones, different time points, and see what were the changes throughout the tables throughout this. And this also has been getting a lot of good feedback from the field.
Yeah, and actually the Iceberg one is pretty interesting because just right, I think maybe a couple of versions prior to 1.0 we introduced that initial support, and we're still kind of fleshing it out. So with 1.0, you're already able to get all the isolation guarantees using lakeFS branches on top of Iceberg tables, which is amazing. And you can even like mix and match those, right? So you can have a repository that has Iceberg tables and Delta tables and a bunch of JPEGs all together, and like get one cohesive version of that. But building on that, one of the things that we are planning on like adding on top of 1.0 is the ability to also like look at diffs at the data level itself. So not just the metadata. So metadata is already like very beneficial, saying that like, okay, I added this partition or modified these two partitions, remove that column, change that schema, but actually looking at the data, right? So show me exactly like which rows were added in this commit. This is all going to build on that infrastructure that was introduced in 1.0. So that's really exciting.
Yeah, and it's funny. I think Iceberg is like one of the, it's so similar to lakeCTL. It's like lakeCTL local. Like we released it and then like the next day there's hundreds of users. So Iceberg, we released it and then like the next day we keep getting a lot of questions. Wait, what about this with Iceberg? What about this? Like we didn't expect that to jump so much. There's a question, by the way, on the Q&A. Let me read it out loud. Is the main benefit of Delta Lake branching if it already has time travel, having a hard time understanding how it works with two different sources of truth between Delta transaction and logs and lakeFS? So Forrest, that's a fantastic and very common question for lakeFS. I actually even have a slide, but for the sake of time, maybe I won't go through it, but a common question is, wait, I have time travel in Delta. I have time travel in Iceberg. Why do I need to use both of them? And the truth is that we have many users that use Delta on top of lakeFS and Iceberg on top of lakeFS. lakeFS is format agnostic, right? It can support Iceberg table, can support Delta tables, or of course, videos and images, as mentioned before. The differences in the use cases, and we actually have a really nice blog that I'm going to try and find soon and paste it here in the answer that talks about the open table format use case versus the versioning use cases. And the idea is that even in the time travel itself, we're not necessarily talking about the time travel of a table. We're talking about the time travel of the repository. So again, think about an ETL that runs and changes 20 tables and the ability to go and see what that looked like before. That's difference number one. Difference number two is in the isolation, right? Think about the use case of developing an ETL against a copy of the data without actually copying it in isolation, right? That's something that even Iceberg that has branches, those are short-lived read-only branches. Those are not completely read-write branches that you can actually work in isolation and have hundreds of environments that you can work on without actually copying anything. And the third thing is around the CI/CD for data that we achieve. So imagine that before you go and you merge, just like you do with Git, that you run automatic tests, you will make sure that you don't have PII data in places that you're not supposed to have it. Or imagine that you can force file format and schema structure and so on, and only promote automatically with hooks, with Git actions, right? To our hooks, changes that you want to in production. So those are the main, I guess, three differences in the use case, besides the obvious, which is you don't have to commit to a structural format using lakeFS. Anything to add on that, Oz?
Yeah, maybe just kind of a pattern to make sure that it's clear, that distinction between that time travel and the versioning that lakeFS offers. So you asked about like two sources of truth, or like the concern around that. So a typical approach, which we just took from Git, it's not something that we made up, is that you have typically that one canonical default branch in lakeFS repo. Let's call it main or prod or something like that. That's your source of truth, right? If I'm now a user and I just want to play around with the data, I can branch off of it. I'm not gonna make the Delta log all dirty with my like ephemeral changes that I might not want to keep. But if I do want to introduce a change, I just merge it back into prod. So the canonical representation is still one, there's just one of those. But you get all that ability of being able to branch, run stuff, and like modify it without breaking anything for anyone else. That's the power that lakeFS provides. And you can utilize it just like Ido mentioned, right? I can branch off of several tables, modify them together, run quality checks to make sure that my changes are as I wanted them to appear, and then merge everything atomically back into my prod branch. That's a common use case.
Yeah, multi-table transactions,
yeah,
things of that nature. Yeah, and by the way, just for the record, like we're obviously, we love Delta tables. We are official partners of Databricks. We work together with Databricks, and we have a couple of shared webinars that you guys can search of Databricks and lakeFS, like Delta and lakeFS better together. So there is zero competition here. This is a better together story. So I don't want it to appear as if we're saying that something is better than the other. It's just very different use cases, and I have shared the link to the document that goes over this in details in the chat of this thing. And maybe if Karen, our colleague, can copy that to LinkedIn as well, that can be useful to have that also. So that's open table formats. The other thing, we kind of talked about the machine learning use case specifically. So that's one thing that really changed the way that we look at a lot of things. So we want to version control the data of machine learning and so on. And we over the last 6 months to a year, I think we developed this ecosystem of best practices that we see already adopted in many of our users, which is, I'm going to version control the data using lakeFS. I'm going to version control the code with Git, and I'm going to manage I don't know if that's manage my experiments with like an ML flow or other experimentation management. And we built a very clear ecosystem and best practices around that include seamlessly being able to use Git and lakeFS together, and Git will not version control lakeFS files or data files, I would say, but we'll still be able to tie those together. So you'll be able to go to a commit in lakeFS and see what version of the code was used for it, and the other way around. And also we be able to go from an experiment, like you can see here on the right, an experiment in ML Flow, and get the exact data set, direct link to this is the data set that was used to train this model. So you can actually go and you can take a new model and train it against the exact same data set and compare those, so you can reproduce. Not to mention things around compliance that we see coming more, like the ability to prove that your data set was correct, which is something that, at least here in the States, is something that you need to do starting last Monday. So it's interesting to see this world come together.
Yeah, maybe one thing to add is kind of something that for us, this is a realization that already happened, but we now see it more common in other parts as well. Essentially, you need 3 pieces, right? 3 things need to happen for your machine learning pipeline to be reproducible. So you need the code to be reproducible, and that's easily solved already using Git. And if you're using a notebook, connect it to Git, make sure that you get those notebooks in version control as well. You need the environment to be reproducible, right? So if I ran using NumPy version X, I should run it again if I want to reproduce it with that exact same version. And then I need my inputs to be reproducible, right? So if I have a deterministic process, I need same logic, the same input in order to get the same output. And that input piece of the puzzle was always missing, right? And this is what lakeFS is really like transforming that area.
Yeah, and once again, if anybody wants a detailed example, there is a QR code here. You're more welcome to scan. I actually don't remember if this is a webinar or the instructions, but it will talk about this use case. I believe it's the webinar. So feel free to...
By the way, another cool one on that slide, I don't know if you have a specific slide for that, but that's DocDB.
I do not have a specific slide about that.
That's one of the coolest features. So we actually embedded DocDB, like a full-blown analytical database, directly into the lakeFS UI, right? So if I navigate and I go to a Parquet file or a CSV file, I can run SQL queries directly on top of that file, all running on my browser on my local machine, right? I don't need to spin up Spark or anything like that. Directly all in the browser. That's really cool.
Yeah, I think that was interesting because yeah, we definitely saw that with the data scientists using lakeFS, like data engineers were very comfortable never seeing a UI, but there was a lot of like manual experimentation, repetition that happens by nature for a data scientist. It's not that anybody's doing anything wrong; they're doing what they're supposed to be doing. So the ability to compare quickly through a graphical interface and see, this is what the data looked like in this experiment, this is what the data looks like in that experiment. We got a lot of positive answers for that as well. Yeah, and I guess maybe one more thing that is really worth talking about is the orchestration. So this is one of those areas that we got also a lot of pool, I would say, and we actually found out about use cases with like solutions like Daxters and Prefect, literally from the field of people using it. That was very interesting. We have the idea here is if you have a DAG or whatever terminology the orchestration tool is using, right? And we created a really easy bi-directional integration from going in a task in a DAG and getting the snapshot of the data as it was before and after every execution, being able to take parallel executions in a DAG and run those on different branches and then merge those together. And that just became a very, very simple, straightforward integration with tools like Daxter that actually have branching in place. And we worked this year with Astronomer. We worked with customers that were using MWAA, like the Airflow solution in Amazon, and the Airflow solution in Google. We worked with Daxter customers, with Perfect customers. And it seems like just because of the nature of the data engineering complexities of someone that is using a full-blown orchestration system that has a lot of different steps, it was a clear place for an integration with something that version controls the data as we go through those changes.
Yeah, and I think maybe the power of that, right? Once you realize what the benefits of this are, it's pretty amazing, right? Because essentially, what are you typically doing with Airflow, right? So you have Airflow itself, which is a distributed system. It's going to orchestrate jobs with, I don't know, Spark or something similar, which is yet another distributed system on top of your object store, which is a distributed storage engine. What could go wrong, right? And like flaky executions, that's something that happens a lot, and they're so hard to debug, right? So I wake up in the middle of the night, Airflow is now red, but by the time I connect everything and I try to reproduce the problem, the environment already changed, right? The next run is going to be green. So even if I think I solved an issue of what caused it to fail last time, how do I test that, right? And just by adding like branch at the beginning, commit and merge at the end, if something fails midway, I have an exact snapshot of what the data looked like when things went wrong. right? I can reiterate on that, make sure that I solve the problem, write a test case. I can do proper engineering, solve the problem, move on with my life. And I think that's very powerful.
Yeah, it's funny. I remember going through one of those tags with a customer, and I remember just the first when it loads and you see the zoom out, and it's like you basically don't see anything. You see like all like errors and blacks, and then there's a tiny red arrow, right? Tiny red box in the middle, and just being able to zoom in, zoom in, zoom in, click right before that box and see, oh, we're missing data that can't be partitioned, right? Something that we were told that would literally take days, took 2 minutes. And you also don't have to redo everything. You don't have to, like typically what people do is, okay, we're going to start everything. Oh, this is a 12-hour task that has to finish before the morning, right? And then you just miss a release day, right? And then, as opposed to starting from that failed task specifically and fixing that and moving forward. So there's a lot of power here, and again, this is one of those things that we got a lot of positive.
Yeah, I think maybe you want to share also the link to the Airflow provider that we have, right? Because that pattern is so easy to implement now. You just drag a box, right? You add the branch operator at the beginning, the commit and merge operator at the end, and you're pretty much done. You don't even have to write the code to do so.
Yeah, and that's a good call out. Thank you. Right here, I tried my best to put like an Airflow icon and a Dagster icon, perfect icon. So if anybody goes to the Airflow icon, you'll see the webinar that includes the operators of Airflow and the sample repository with Airflow and lakeFS that you can spin up and play with it. There's really a lot of power to the lakeFS sample. So anybody that wants to play with the data, we invested a lot over the last couple of years in creating a very, very broad example set that you can work on, and you can use that. So thanks for calling that out. Okay, so 1.0 is out. Besides being like a nice round number, what are we guaranteeing going forward?
Okay, so that's a good question. So lakeFS tries to adhere to SEMVer. We'll put a link to that below. But essentially, graduating from being 0 point something to 1 point something essentially means we ensure stability. And that means that all the releases from 1.0 to 1 point, whatever the last number would be, are all going to be forwards and backwards compatible. Right. So if I'm using the Python SDK on the client and a lakeFS server running two different versions, but they're both 1 point something, we guarantee and we test that those versions are compatible with one another. Right. So I don't have to like orchestrate exactly when I'm upgrading my server that all my clients need to upgrade at the same time. Right. Make sure that this compatibility happens. This happens in the lakeFS server, on the lakectl command line, as well as the Python and Java SDKs. Right, so we get pretty much the entire spectrum of things, all guaranteeing that they're cross-compatible across different versions on the 1 point something branch. So that alone, I think, is it's a very good guarantee to have, right? And it allows you to build something that's robust and doesn't break.
Yeah.
So SDK and CLI are all going to be compatible across versions. And the next thing, and I think maybe that's one of the most important ones, is that unlike 0 point something versions, where if we do find a security related issue, we wouldn't give specifically a guarantee about older versions also receiving that security update. We are going to give that with 1.x. Okay, so we want to extend that support as far as June 2025, or phasing out 1.x to 2.x. Actually, whatever comes later, right? So I want to make sure that if you're running lakeFS, you get to enjoy all the right security patches and updates that are required without having to introduce breaking changes just because a bug was fixed or the security issue was fixed. So we've been pretty diligent on this until now, but here it's a written guarantee and something we take very seriously.
Yeah, so hint to anybody not on 1.0, maybe this is a good idea to move forward well.
Yeah, absolutely. And the last thing, just like any other release of a major version, bug fixes, support, stability issues, anything that comes up while we're still on 1.x, will receive those updates. And even after we release, let's say we even decide to release 2.x half a year from now, you're good for at least another year, right? Until the end of 2024, October 2024. We're going to continue releasing bug fixes, small improvements, performance issues, anything that comes up will be guaranteed to be fixed. Okay, not just for newer versions, but also for 1.x.
Yeah, so I mean, we're almost at time, but any like in a high level, how do you look at the next steps of lakeFS without going to the roadmap, which is of course available as an open source project?
Yeah, and let's make sure to also share that. So I think 1.x is definitely a huge milestone, and having those stable APIs in place is not just great for users of lakeFS, but also like anyone in the community or maintainers of lakeFS get to enjoy it. So now we can actually build on top of those APIs and start adding like more user-friendly layers on top. So we plan to improve the Python SDK to make it much more user-friendly. We actually had a community contribution of an FS spec implementation. For those of you in the Python landscape, that's a really cool utility that allows you to easily connect stuff like pandas and polars and other Python libraries directly to your storage. So we plan on also integrating deeper with that. A lot of focus around security and governance features, especially now that it becomes such a big part of ML. And of course, continuing to improve on scalability, on security, on stability, everything we've been doing, just doubling down on all of that. Do expect some big things coming around like Delta and Iceberg. That's definitely an area of focus. And of course, working closely with the storage providers. Hint, hint, reInvent is a month from now. Going to be an interesting one for us at least.
Yeah. I'm very excited for what's coming up in reInvent. And by the way, Oz and I will be in reInvent, so if anybody wants to meet us in person there, please feel free to reach out as well. And the links for both the roadmap and Semver are on the chat if anybody is interested. So, and the last thing, just to as we talk about this, look, the community is ever growing, and we were so fortunate and so grateful to have this incredible community with a lot of like nice good names, and this is obviously just a very small subset of them with the Slack that just keeps growing. And if you want to be a part of the party, then you have a link here to join our Slack. You can go to lakefs.io/Slack and join as well. Would love to have you there. It's a great question to ask questions. It's a great place to ask questions about lakeFS and get feedback. And the more the merrier. We're happy to have anybody there. So yeah, Oz, this was fun.
It was. And actually, I'm so excited to see that so many people ended up joining this conversation. We had some questions along the way. I think the channels are still open. So if anyone has any further questions, either on the webinar on Zoom or on LinkedIn, or of course on our Slack, that's always an option. We'd be more than happy to keep the discussion going.
Let's see. We'll give it a few minutes. We'll see if there's any additional questions. Oh, there might be. Wait. Oh, sorry. Oh, this is the roadmap, by the way. I clicked it by accident when I tried to see if there's questions. Okay.
Yeah, we're good.
Oh no! Wait, there's two questions.
Oh, okay.
Two questions. Let's see. One is if we're using BigQuery, is lakeFS an alternative, or what is the difference?
Oh, okay. So there is no official support for BigQuery yet. I'm hoping that would change in the future. That's something to look out for. We do see a trend around like the data warehousing providers, BigQuery being one of those, with support for like open table formats and object stores in general. So I think we'll come to them, they'll come to us. This is already looking like it's shaping up to be technically very feasible. So I would expect, hopefully by 2.0, to have that support in place. It's not there yet, so hopefully soon.
Yeah, and the other question is one of my favorite, is there support for fast forward merge?
That's a good one. So currently lakeFS would create a merge commit on any merge. So there is no like technical, just like in Git, where you just move that commit to be the head of the next one. This doesn't exist, but lakeFS behind the scenes is efficient enough to not rewrite metadata when there were no changes on the destination branch. That's a very deep answer. Happy to elaborate more on like Slack or on a GitHub issue if that's something you're interested in.
Yeah, this was an anonymous user, and it's a very short question that can mean a lot of things to a lot of people. So I will say that there's different use cases for fast forward merges, and some of them we do today. Like for example, a lot of time people want like this sort of rebase for late arriving data for reprocessing or things like that. That those are happening every day with lakeFS users, and there's rules for them. Fast forward commit, there's also use cases for that have to do with open table formats, like if I change the same table in more than one place. And those are things that we're actively working on that are in the roadmap, as you can see, as you look at it. So there's different elements to this, and happy to answer in more details if anybody is interested in having the conversation.
Yeah, thank you.
Awesome. So thank you for the questions, many good questions. We're hanging right here. Let's see any questions on LinkedIn. LinkedIn has been very quiet this time, and Zoom has been on fire. So every time it's a surprise for me.
Bring you on your toes.
Yeah, exactly. Okay, so we're gonna wait 20 more seconds before we end this, just because there is a little bit of a delay with streaming on LinkedIn, and we'll stop. So thanks again, Oz.
Yeah, thank you. Did we answer all the Q&A on the Zoom? So I see there were a few questions. Yeah, I see that they're all answered now. Cool.
Yeah. Thanks, everyone.
Okay.
Have a good one. Bye-bye.
Thank you, everyone.